Hello, welcome to Unit 3. In this unit, we'll introduce linear regression and a number of ways we use for creating and testing machine learning models. Now, linear regression is really a more basic statistical analysis technique, and if you've had a stats class, you've most likely covered it along with a number of other science-based classes. So it's a common method, and it's not really machine learning, but it's a nice stepping stone to our algorithms for next unit 4. And then you'll have a practice activity this unit too. Now you'll start getting into the flow of this course, and this is kind of an odd number unit, and so we just have a practice activity, no project, and next unit we'll have a practice activity and a project. So some students will start wanting to get an early start and finish this unit and start unit 4 early, and so I'll tend to release unit 4 early so that if you want to get going on that during this week, you can also. What is linear regression? Here's a couple articles that go through a simple explanation of it. This is one from Jonathan Wood. It talks about, wrong one, linear regression, and has a good overview of it. Without getting too technical, it talks about lines and how we do it, and then talks about how we import some libraries. And we're going to be using some new libraries in Python, the sklearn library in particular, that we'll be using from now on in this course here. One thing that's important to start looking at is we'll be working with data sets, and we'll be splitting these data sets up into some data used for training our model or setting up our model, and then some data used for evaluating our model. Our models are going to get more efficient and stuff, and so one thing they're able to do is memorize our data. So if we have some complicated data and we run a lot of training, our machine learning model will basically memorize every data point in here and be able to categorize it or predict it. But that doesn't lead for very good predictability in new data that we haven't seen. It doesn't generalize well. And then sometimes we also see underfitting, which is the opposite, where we have this data and we do not train it enough and we don't get a good approximation for this. So splitting our data here into what is called a training set and a testing set will help us evaluate. We'll use the test set to see how well we're doing on new data that the training algorithm has never seen for this. So usually we'll do like a 70-30 split. We'll take like 70% of the data and use that for training and reserve 30% for testing. Sometimes it may be an 80-20 split, but we always want to now start saving some of the data and having the algorithm not see that data and not train the algorithm on it, and then test how efficient the algorithm is on this new data that it hasn't seen before. So we'll do this in our areas here. Now, some of this other stuff is not, so they're just talking about exploring our data and trying to looking at this. You can read through this. Talk about building our model here and what we're using there, predicting salaries here for things, and then creating a linear regression model and then training it, fitting it. And again, this is a linear regression model, but again, we'll see the same sort of system next unit when we look at 3 different machine learning algorithms, and even when we get into our more complicated neural network algorithms, we'll set up, we'll declare our learning algorithm, and then we'll fit it with our training set here. And then once we do that, we'll then generally test it. We'll score it or use it, so we'll somehow test it with our test data. So we'll walk you through this more in our practice activity. But I thought you might want to read through this introduction to this linear regression if you haven't seen it before in a stats class, because again, you're not required to take a stats class before this. This other article is another introduction to the same basic material. And goes over what regression is, talks about how it has a simple sample of it, and does a little more talk about correlations and how we can see correlations for this. This uses some U.S. housing data and tries to predict the housing prices based on that, and imports that into a Panda data frame. It does some graphing here showing some of the correlations here. You can see some of them have some correlations here. Talks about what a correlation is and how we measure it. Introduces this heat map. And the heat map is one way to look at all the variables in a grid and see how closely they are correlated with each other for this. And later on we'll use this sort of map again, but again, it's not too critical at this point, but for some of you who are familiar with this, you might want to read this. If you're not, you might want to look up more heat map stuff. Some students actually did heat maps for the visualization last unit. So. Okay, the linear regression model is set up here. They're selecting what fields they're going to use to train the model and what they're using to predict. They're predicting the price given these other attributes. And again, they're setting up this training testing split here for this. And here they're doing a 60-40 split, it looks like. So they're reserving 40% of the data for testing here. And then they're creating their linear regression model and then fitting it using the training data. And then later on they'll test it, they'll do some predictions with just the test data and see how well it does. But again, much of this is also covered in this Learning Practice 3, where we'll go through data and do some predictions with this here. And again, we'll be using the housing data similar to what was used in that last example and walk you through that. And there's a video with more details posted here. The last thing is, if you're interested to see how things went with the last project, I posted some highlights in a notebook, kind of collecting some of the best and some suggestions of what was expected as far as the writing goes. So if you want to look at the project one highlight, you can for that. And again, remember, we'll be doing discussions this week and next, so post your discussions. Tried to clarify more what I wanted. What are some good titles? It's important with this new Brightspace system to try to use some good titles and not some just hard to read titles. And then talking about some details, including the text of the question or a link to a notebook or actual sample code in your questions. All those are helpful when posting questions. So, okay, that's your introduction to this unit.